Welcome! In this video we're going to cover scope, how it affects when and where you can use variables, and some design tips based around scope. So we have this general problem in programming that we are working with lots of data, and as programs get big and complex, what we don't want is to have every piece of data available from everywhere. It just becomes too big a mess, too much to kind of keep in any programmer's mind. So we want to limit where particular pieces of data can be accessed from, and we want a way to clean up after ourselves. If we use a piece of data and then we're done with it, we want to be able to get rid of it. We don't want it sitting around cluttering up our memory, and we want to possibly be able to reuse that name. If I'm writing a program in using geometry, I probably want to be able to use the variable name x in more than one spot in the program. So to accomplish these goals, to allow us to kind of use the same name in different places in our code, to avoid keeping things around for too long, we have this mechanism called scope. And scope is simply the idea of the lifespan of a variable, where it's available from. And in C++, the kind of basic rule for scope is it's going to be defined by the block in which a variable is declared. A block is a region of the code that is surrounded by the curly braces. So here is a block of code starting at line 10 and going to line 19. Anything that I declare inside this block, like x, is going to be available anywhere inside of this block. So from lines 10 through 19, I can talk about x. And I shouldn't do it before I declare it, but on all the rest of the lines in this block, I can talk about x. Y is in a narrower scope. Y is only defined in this block because y was declared inside this block that starts on line 13 and ends on 16. So that means the only places I can talk about y are inside here. Once we leave this block, y essentially goes away. And it is now an error down here on line 19 to talk about it. Y is now undefined. It's like it never existed. As we enter the block, y becomes something we can talk about. As we leave the block, it goes away. Now we can actually see this play out in code. To do that, we're going to go use the debugger to watch this code run. So I've put a breakpoint on line 11. I just click there to turn on that red circle. I'm going to hit F5 to start debugging. And we get to this line. Notice that my locals, the variables that are available for me to work with, to think about, only include x at this point. And currently x has not been set, so it's got some default value. It happens to be 0. There's no guarantee it's going to be 0. It's just not been set yet. So I'm going to go ahead and run this line of code. Step over. That happens. We come into this narrower block, and now all of a sudden there's a y. Now we haven't set y to be 2 yet, so it's got some default value, and it just happens to be 8, right? We no way to predict what that is. And so great, I now set y to be 2. And I still could talk about x. I can talk about y. So it's fine to print y. And then as we leave this block and I step onto the next line, y is now gone. All right, it's completely disappeared. It is no longer something that is valid to talk about. Now, it is perfectly valid in a narrower scope to talk about a variable that already exists. We just saw that when we enter this inner block that starts here on line 13, x does not go away. X is still there. So as I enter this block, if I change x to be 4, that is changing this variable x that already exists to be 4. And when I print it out, it's going to be 4. Right? So we can, when we go into a narrower scope, a new block, we keep all the existing variables and we can keep working with them. But we can also create new ones, and any new ones that we create, that we declare inside the block, those are the ones that are going to go away. Right? We're going to keep changes that are made to existing variables that were declared outside of this narrow scope. but we're going to discard any brand new variables that were made as we leave that narrow scope. It is possible to declare a new variable with the same name in a nested scope. Now this would be, I've got int x gets set to 1 on line 11. Line 14, I say int x gets set to 4. If you try and declare the same variable twice in the same block, in the same scope, you're going to get a compiler error. If on line 12 I wrote int x gets 2, the compiler would say, I don't know what to do with this. You can't have two different variables named x in this block. When you declare a new variable inside a nested block, like I'm doing on line 14, what it assumes is, oh, you want some new variable x, and basically now as soon as I do that on line 14, anytime I talk about x inside this block, I'm talking about some new variable x that's different than the x that exists already. This is called shadowing. We're making a new x that shadows, that hides, that blocks out the existing x. This is never really something you want to do. It's almost always going to be something you do by accident, right? You forget that you've already typed int x and declared the variable, and you're going to work with x, and you by accident declare it again, and it's not an error. So your program runs and just doesn't do what you expect. Because if I try and change x here, and I think I'm changing that x, well, I'm not. I'm changing this new x. And when I go ahead and print out x down here at line 19, I will still have the value of 1. This will show up as a warning. Declaration of x shadows a previous local. Well, that's telling me that there's a problem. But again, my code will run. This is not a compiler error, so the code will run and it'll just give me a warning. Are you sure you know what you're doing here? So watch out for that warning. Remember that shadow means you're hiding something that already exists, and you probably don't want to do that. Now, because variables go away as we leave the scope they were declared, that means we potentially have a problem. So this little program, I ask for a price, and then using the price, if it's less than $50, I want shipping to be $5.50. Otherwise, if it's more expensive, shipping is only $3. And I want to figure out the price, the total price, by adding the price of the item plus the shipping, and that's my total. Well, this code doesn't work. Shipping was not declared on line 23 because there was one shipping variable from line 16 to 18. And then when we get to line 18, that goes away. And either I had that one, or maybe I went into the else, and on line 19, a shipping variable became available in that block. And then, on line 21, it goes away. Either way, there is no shipping down here. Now, one way we might solve this problem and make the shipping value available is to do all the work in the if or else. So if the price is less than 50, set shipping, figure out the total, and print out the total. Now this works because shipping is talking about this variable that's in the same block. That makes sense. Price is talking about this variable that already exists from the outer block. That makes sense. Right? Like technically this works. But this is an important design tip. Anytime you find yourself copying and pasting big chunks of code, you're doing it wrong. There's almost always a better way to do that. Now, sometimes it will be the case that you just don't know the right trick yet, but in this case, we can do better. Having the same code more than once makes it harder to read, harder to maintain. If you've got a bug in that code, you've got to go find it and fix it in a whole bunch of places. We don't want to see this. So, how do we fix the problem in a better way? Well, the answer is to declare the variable shipping in the scope where I need to use it. Make sure that it lasts until line 23. And I'm doing that here by declaring it out in the scope of the main function that began up on line 10. And because I've declared it on line 16, outside of these narrow blocks for the if and the else, I then go in to the if, or I go into the else, and I put a value into shipping. And then when I get to line 23, I can just use that value that was set by one of those two, and shipping still exists. And I'm not duplicating these lines of code on line 23 and 24. This is kind of the right way to do it. Now, you probably could make this even better. Most programmers would probably say an even better version of this would be just make sure that shipping always has a valid value. This one, shipping doesn't start off with a valid initial value. And we're counting on the fact that we're either going to do the if or the else, and that's going to put a value in it. But sometimes you write your logic and there's a way for the logic to fall through and not hit any of the if or else's, and then you end up with weird behavior because you've got some uninitialized variable. So most programmers prefer to make sure that when you make a variable, when you declare a variable, you give it some value. And then if I just assume that shipping is going to be $3, kind of the expensive item shipping, then I can just say, well, if the price is less than 50, then let's change the shipping and just treat that as a special case that changes the default. But either one of these are vastly superior to this one, which works, but is ugly because it duplicates code. Another design tip, second design tip. We want to use scope to limit the amount of space variables are available for. You should try to declare variables as late as possible for them to work correctly. We do not want to start off a function, including the main function in our program, by listing every possible variable that we're going to use. This is kind of cognitive overload for whoever's reading your code. Wait, there's going to be hours and overtime hours and pay rate and salary and employee type and pay and there's so much to keep track of. It also is going to be more error prone especially when we get into doing things like loops. It's a lot easier to make errors when variables stick around too long. So what's the better way to write a program where I'm using all these variables? Well, it's going to be to just declare them when I need them. So this particular program is designed to figure out someone's salary. And so first off, we start by figuring out, are they a salaried employee or an hourly? So I'm just asking, enter 0 for salaried or 1 for hourly. And that is stored into employee type. So we need this employee type variable that is going to hold 0 or 1. I declare some constants right by it because those kind of go with this employee type, that salaried employee is going to be 0 and hourly is going to be 1. And I'm going to need them to check, like, if the employee type is salaried, here's what to do. If the employee type is hourly, here's what to do. Then what I want to do is, my end goal is to calculate their paycheck. I'm going to go ahead and switch over to Visual Studio Code here. Here is the program. Just, I can scroll down and show you the final goal is to print out, here's the paycheck. We're going to, either way, whether someone is hourly or salaried, we want to determine their paycheck and print it out. Anything that happens no matter what doesn't belong inside an if or else, right? No matter what, I need to know what kind of employee it is. So that comes before my if else. No matter what, I need to print out their paycheck. I can't do that until after the if else logic, but this always happens, so it doesn't belong in the if else. The things that happen only some of the time, those belong inside my conditions, inside my if and else. So, like salary. A salaried employee has a salary. An hourly employee doesn't have a salary. They get an hourly rate. So this salary, asking for the salary and having this variable for the salary, none of that belongs out here in kind of the general part of the program. Right? That logic only belongs in here where I know I'm dealing with salaried employees. So I get the salary, do the math, and I use that to set the pay. If the person's hourly, I need to get the hours worked and the pay rate, and then I have to do some calculations to figure out if they get overtime because they worked over 40 hours. Right? None of that is going to apply if they were salaried. So it doesn't belong out here in the general part, it's just where we need it. And then I calculate their pay. Now, either way, I've calculated this pay variable. I've assigned it a value, and so when we get down, we can print out the pay. That pay variable, I need it to last after the kind of the if and else are done. Right? I need to make use of it down here. So pay, this is a spot where I can't put the double pay inside my code here, because then it's not going to be available down there. Right? And if I do it in both places, that still doesn't fix the problem, because I'm creating this pay and then it goes away immediately. So sometimes we have to declare a variable a little bit early. In this case, I have to kind of declare this really before I'm ready to work with it. But I need to do that so it exists in this outer scope. Right? But unless you have a reason like that, you really shouldn't declare a variable unless you're ready to work with it. Right? Pay rate, I don't talk about until the first time that I need to deal with the pay rate. Overtime hours, I don't declare that variable until I'm ready to make some decisions and do some work with it. But I need this variable to last, kind of to exist, whether or not we go into this if, so it's declared outside the if right before I'm ready to do my calculations with it.